Welcome to Lesson 3.5 of our Payload course. In this lesson, we'll focus on adding powerful pagination and search functionality to our project. These features will enhance scalability and user experience by enabling efficient data exploration. Along the way, we'll dive into the best practices for leveraging Payload's query capabilities. Consider this: as your dataset grows, how can you ensure users can still find the information they need quickly? That's where these tools shine. Let's explore how we can implement search and pagination step by step. The qs-esm library is a simple yet powerful tool for building query strings in JavaScript. In this lesson, we'll use it to construct queries for fetching data from Payload dynamically. Query strings allow us to filter, sort, and paginate data seamlessly. For instance, if a user is looking for blog posts that contain a specific keyword, we can use qs-esm to craft a dynamic query string. Notice how this example keeps the code clean and flexible. This approach ensures our API calls are efficient and maintainable, especially as our dataset grows. Why is this important? Because as developers, we want to write code that scales. Efficient query construction saves bandwidth and reduces back-end processing time, a win for both developers and users. Let's create a search bar component that interacts with our Payload backend to fetch and display filtered data in real time. This component will include several key features: managing state with useState for the search query and results, a fetch post function to query the CMS dynamically, and debouncing the input to minimize API calls and optimize performance. Here's an example. By adding debounce functionality, we can further optimize this component to reduce unnecessary calls. This keeps the application responsive while minimizing load on the backend. Payload's where and select options are essential for optimizing data queries. The where clause filters records based on conditions, while select limits the fields returned, reducing payload size and improving performance. For example, let's break this down. The where clause ensures only relevant posts are fetched. The select parameter minimizes the data payload, reducing load time. And sorting by publish date ensures users see the most recent content first. These optimizations become critical as the number of records in your database grows. Imagine querying thousands of records. Being precise ensures a fast, reliable experience for users. To make searching even more robust, we can integrate the Payload Search plugin. This plugin indexes collections and provides optimized search capabilities. Here are the steps: install the plugin, and then add it to the Payload configuration, and then rebuild your project and test the search functionality. Why use the plugin? It reduces the manual effort required to build complex search functionalities while improving search relevance and speed. This is especially useful when handling large datasets. Combining search and pagination ensures the large datasets remain easy to navigate and explore. Here's how we can implement both. This query retrieves 10 results per page, sorted by publish date. Additionally, the metadata returned, such as total docs, has next page, and current page, enables us to build intuitive navigation components. Why is this important? Because user expectations for performance and ease of use are higher than ever. Combining these features ensures users can find exactly what they need regardless of how large your dataset grows. Let's see these features in action with a quick demo. We'll perform a dynamic search on the client side, and we'll perform a search using the plugin on the admin side. As we go through the demo, here are some best practices to keep in mind. Optimize queries, use select and limit to minimize payload size, implement debouncing, prevent excessive API calls by debouncing search input, monitor performance, use payload logs to track query efficiency, test extensively, simulate real-world scenarios with large datasets to identify potential bottlenecks. By following these steps, you can ensure your application remains efficient, user-friendly, and scalable. In Lesson 3.5, we explored how to implement powerful search and pagination features using Payload. We covered querying with qs-esm, optimizing data retrieval with where and select, setting up a search bar and configuring the search plugin, and combining search with pagination for large datasets. Remember, these tools are not just about functionality, they're about creating seamless, scalable user experiences. In the next lesson, we'll explore how to optimize your project for SEO and performance. These optimizations will ensure that your application not only functions well, but also ranks higher in search engine results and provides a faster user experience. We'll see you there.